Dr. Alexander Tournier from Germany is going to talk to us about the physicochemical investigations of homeopathic preparations.
Thank you very much, Professor Hahn. It's a great pleasure to be able to present to you the results of, or some of the results, because not all the results are yet available, of a review, a systematic review we've been undertaking with Sir Stefan Baumgartner, Sandra Württemberger, who are here, and Sabine Klein and Ursula Wolf. So we really wanted to go really at the foundation of the problem. What do we have in terms of physicochemistry in homeopathy? What do we understand? So we really wanted to go back and look at all the physicochemical experimentations that have been performed in homeopathy and summarize all that evidence. The only evidence we have in that is a review by Claudia Witt, but it was just a bibliographic overview, and we wanted to go further and extract really information to inform future research. So what are the most promising techniques and what are the best experiments to do in the future? And also to go even beyond and really try and understand and try and tease out what we've understood so far, what are the parameters that are appearing in terms of our understanding of the mode of action of homeopathic medicines when we look at them through the eye of physicochemistry. So the review process is in 3 parts. 2 of them are now published. And so I will talk about all 3 parts a bit. The first part, we found 183 publications dealing with physicochemistry in homeopathy. We assessed them for the quality of the publication. We cannot assess directly the quality of the research, but at least we can assess the quality of the publication. And if you do that, we found 122. And in the first review, part 1, we analyzed then these 122. In part 2, we updated our literature search up to end of 2018, founding another 19 publications, bringing our total number of publications to 134. These 134 publications that describe 203 experiments, individual experiments in physicochemistry in homeopathy. So, as I said, the part 1 is published in JACM last year actually now, and I'm really glad to be able to say that part 2 has just been accepted. This is taken from the proof I got yesterday or the day before. So it's really, it's going to appear online very shortly. So to give you an idea of what we undertook in part 1, we scored every manuscript according to this manuscript information score that really tells you, but we wanted to score how well the authors reported on things like experimental procedure, how well they told us about the material they used, where they came from, what kind of measuring instruments they used, exactly what the calibration and so on, what kind of potentization methods, how did they prepare these homeopathic substances, how well is that described, and also what types of controls they used, how well they took care of the controls, at least in the publication. So with that, we were able to score all the manuscripts, and we established, or we took as a minimum requirement for us to look deeper into the studies, that they should have a score of 5 or above at least. And so if you use that type of scoring, so MIS equal to 4, so that's what we will call medium or above quality, you can see that over the years, the number of publications goes up, the number of high or medium or high quality publication increases sharply after 2000, so that's very promising. And also, we just see a general increase over time, so that's also promising for the field. If we look then, so this is part 1 of the study that looked into this. If we look at the data per country, so overall, the number of publications, we see that 4 countries really dominate. Germany published a lot, followed by France, India, and Italy. The picture changes somewhat when you look at after 2000. As you saw, there's quite a transition around 2000. And there, it's really Italy, India, and Germany. And we see, sadly, that France just has completely fallen out of the list after 2000. There we saw that the methods most used were electrical impedance, analytical methods, spectroscopy, and NMR. I will go into these methods more later. In part 2, we wanted to go beyond, and we wanted to concentrate really on the high-quality ones, and we wanted to pull out the individual experiments from each publication. A publication can describe several experiments, and we wanted to think really in terms of experiments rather than publication, and actually extract the information for each experiment. And when I say information, we really went to town, so to speak, in terms of the amount of information we extracted. I'm not going to go into detail because it's too much, but we extracted a lot of information about all the experiments so that we could extract some interesting information, which I'm going now to tell you about. So one of the most interesting results, of course, for us is, did they report positive findings? Did they say they found a difference between verum and placebo? Are the homeopathic remedies different from the controls? And indeed, like most of them, 73%, did report finding differences between the homeopathic preparations and the control. So that's very encouraging. Of course, in science, this type of data, we have to be very careful because this is where publication bias comes in big time, because of course we are all tempted to only publish positive results. But it remains very promising. Notice that here there's 9% of experiments that were not specifically looking at answering the question, are homeopathic preparation different than placebo? So that's why they're not applicable. So that actually would increase the overall ratio of positive findings. Now, if we go into more detail, the type of things that we looked at in terms of what people did, what type of methodologies, and what we then extracted as information for the future, and kind of like recommendations. If you look, for example, at randomization, you see that actually relatively few studies use randomization, only 20%. And the problem is, if in a lot of experiments, there are subtle effects due to time, the way if you do your experiments in time, you might just have a time effect. So if you do your placebo and then your verum, there might just be a time difference that you're measuring, or a spatial difference that you'll be measuring. And if you're not careful, that is the type of effect you will see, and it will look significant, but actually it's not, and you need to randomize it away. So this is something that we really recommend that people do more of. In terms of the controls used, we saw that most of the experiments use unsuccussed medium, such as just plain water, for example, or 90% ethanol, as the case may be, which is a fine control if you're just trying to say to find the presence of say, nanostructures or water structures. Is there something different? Now, if you want to say, find out if there is a specific signature of, say, sulfur, is something specific about sulfur 30? Is sulfur 30 really different from normal water? Then you really need to look at succussed control, because at the succussed controls, you'll have all these unspecific effects which are due to the succussion. So inclusion of nanobubbles, nanogases, leaching from the glass walls, all that is going to influence your physical sample, and by that effect alone, going to create a difference. And if you're not careful, you're going to see just that difference, and that is not really due to the remedy itself, but just to the succussion process. So for that, you really need to be looking at succussed control or potentized medium. And then we looked at blinding. Again, few experiments report using blinding. Traditionally, in kind of fundamental research, we do not use blinding because we assume that all these experiments are done by machines and that they're not subject to any kind of bias. However, considering the contention around the field, we recommend that people use blinding so that there's no any perception of bias by the experimenters. Further, the use of statistics, only 28% of studies actually used what we call modern or inferential statistics. Those are the statistics that gives you a p-value or a confidence interval that allow you to say this is significant or not. So this is, we would say, very important, especially considering the contention in the field. We need to be able to say this was significant. Independent production lots are an interesting concept that was brought about mostly by de Monja in MR. And the idea here is if you take one verum and you compare it to one control, and you measure those multiple times, many times, eventually you will find a difference between the two. This difference will not be significant. It's just a fluke difference. At some point, if you measure them enough, you will see a difference. And it will look to you as if it's statistically significant. The way around that is to start from scratch and remake the samples from scratch multiple times and measure them multiple times from redoing them. So you will have a distribution of your verum and a distribution of your controls, and you can then assess whether they're really different or not. So this is the idea of independent production lots, which is something that we recommend as well doing. In terms of the potencies used, most experiments used mixed potencies, that is both below and above Avogadro's number, and about 20% used potencies that were above Avogadro's that would then test this idea beyond the limit of Avogadro. In terms of what substances were used, you get your usual suspects. NIR, this interesting fellow is used by Professor Elia in Italy. He's pretty much the only person who's been using that remedy. All the others, as you can see, are the usual suspects you would use. And it's also very interesting to be building this database of experiments in those remedies, because the more we focus on specific remedies, the more we can know more about that. And this is also the effort around Leonie Bonamin's efforts, and that's been around zinc, and now we're attempting NIR. And it's really interesting to be building the database on specific remedies. Now, we wanted, as I said, to look at promising methods. For that, we scored the methods in terms of what's called MFI score, which is basically looking at the quality. Did it do blinding randomization statistics? So did they use all these things? And then did they report positive findings? If you combine all this, then you can make a score that tells you, well, is this experiment of high quality and did it find positive findings? Then you find that NMR has a very high score and therefore should be a priority for us. And also spectroscopy, very high score, should be a priority for us to repeat these experiments so that we really find out what's happening there. And then you have also electrical methods, impedance, and imaging methods are coming through again. Now, also, if you look at replications, we define a replication as an experiment that used the same method, so extracted the same physicochemical parameters for the same remedy, but maybe in a different potency, with the same remedy. So here, what we see is that we can score them again by how many replications, whether they're positive and the average quality. And there, NMR, for example, of silica scores very highly. So giving us, again, that's an area where it's been reproduced already many times. It's given positive results. It's high quality each time. Let's do it again. So this is areas where we can say, let's do that more and more. It's histamine, again, and spectroscopy of sulfur and cuprum sulfur are coming through. Now, what have we learned? So NMR, for example, 30 publications, mostly from de Monja, see differences in T1 and T2 relaxation times that are really indicative of a change in the dynamical structure of the water. Now, 3 replication studies tried to replicate it, were unsuccessful. Most of the replications are still internal, mostly de Monja. So again, an area where we need more efforts. Spectroscopy, even more publications in the UV, visible, and in infrared. They see increases in absorbance, changes in the absorbance spectrum, narrowing or shift, or in the OH stretch band that has a peak that we can see. And interestingly, also, people used certain molecules as probes of the presence of homeopathic dilution. So they use bovine serum albumin or polar dyes, and that's the work of Stephen Cartwright, who's going to work to present later in the conference. Electroimpedance, 42 experiments, general increase in conductivity reported, also increase in conductivity according to aging. And interestingly, many of the experiments were not done in pure water, but use solutions of sodium bicarbonate or silicic acid as the medium. Finally, I just wanted to mention analytical methods and imaging methods. 22 analytical methods, 16 imaging methods. These were traditionally used to prove the law of dilution, to make sure that it was doing what we thought it was doing, or looking at leaching effects. And recently, it's really been used to track the nanoparticle hypothesis. Now, as I said, take-home message is your controls, make sure that the controls are specific to what you're trying to assess. Are you trying to look for specific effects, notion of information, looking at sulfur specifically, or are you looking at nanostructures, and then your unsuccessful medium will be the trick. The medium you're using, people have reported, actually, de Mangin reported much better effects in saline or in lithium chloride, for example, than in pure water. So we should be aware that groups are using not a pure solvent as a medium and reporting better results using those. To bias and prevention, as I said, randomization, blinding, and also use of negative and positive controls in systematic controls. These are experiments that really allow you to ascertain whether your level of false positives and false negatives in the experiment, which is very important if you have a very sensitive assay. You really want to know how sensitive is my assay before I say I have a positive finding. And again, I said, use of statistics is very important. Unfortunately, I was not able to, the review was not able to capture some interesting work, in particular the work of Professor Konovalov, which Professor Voykov is going to present later, because it was not specific to homeopathy, and our review had the keyword homeopathy in it, so it didn't fall in there. And also the work of Professor Pollack, also not being specific to homeopathy, the whole exploration of exclusion zone by Professor Pollack was outside the scope. But these remain very interesting areas that need further investigation. So, conclusions. There's a lot of things to be done. Interestingly, NMR and spectroscopy are techniques we really recommend should be looked at further. There's a lot of interesting hypotheses being tackled. We're discovering a lot of interesting stuff through the review and in general. So basically, we need more funding to undertake the research. And with that, I thank you very much. And this is the lab in Heidelberg.